Assalamualaikum and hello everyone. I'm Alfikari binti Ujang, student from section 1. So we are going to talk about elastomers, structures and properties. So as you know, what are elastomers? An elastomers is a polymer with viscoelasticity. Young modulus is low and failure strength is high compared with other materials. Rubbery element and compound, and it's referred as a memory. So we can see here, this is unstressed polymer and stressed polymer. Elastomers are solids that resemble rubber and have elastic characteristics. These materials have polymer chains that are kept together by intermolecular connections that are relatively weak, allowing the polymers to elongate as in reaction to the macroscopic stresses. This is the example. This is natural rubber, synthetic rubber, polyurethane, neoprene, fluoroelastomers. So this is the types of elastomers. We have three types of elastomers. First, general purpose elastomers, specialty elastomers, and thermoplastic elastomers. As we can see, we have styrene butadiene rubber (SBR), polybutadiene rubber (BR), polyisoprene (NR), natural rubber (NR), synthetic rubber (SR). For specialty elastomer, we have nitrile rubber (NBR), butyl rubber (IIR), silicone rubber, fluorocarbon rubber, urethane rubber (UR), and for the thermoplastic elastomer, we have aliphatic thermoset elastomers, polyamide elastomers, polypropylene elastomers, and TPO. So, how to know the elastomers property? We have to know elastomers properties from the temperature, low temperature flexibility, hardness, edging, color, and elongation at break. For the temperature, according to the variables including media, compatibility, seal design, and dynamic and static operation, elastomer specific working temperatures might vary. For the low temperature flexibility, by putting elastomeric material to low temperature filtration, the rate of recovery can be investigated. By measuring hardness, one can determine the material resistant to deforming force for a specific amount of time. It's very depending of the substance. The tougher compound have strong resistance and low frictions, whereas the soft compound easily deform and have high friction. For edging, the attribute help in understanding materials behavior when subjected to heat. Hardening, cracking, and splitting will occur if the elastomers are pushed beyond the edging resistance. Color. Coloration is mostly used to distinguish compound grades based on their intended application. For elongation at break, when tensile stress is applied to material, this attribute is utilized to determine the moment of rupture. As we can see, this is natural rubber. Okay. This is natural rubber, is derived from the latex of the rubber tree and found more than 1,000 plus species, but species are used in industry is limited. We can see here, this is the structure of natural rubber. For the properties, we know natural rubber, high tensile and tear strength, resistant to wear, abrasion and fatigue, high molecular weight, rubber is water repellent, resistant to alkaline and weak acids. For the polybutadiene rubber, BR. Butadiene is made by dehydrogenating butane or breaking petroleum. This is the BR structures. For the properties of BR, we know that BR is excellent abrasion resistant, elasticity, and cold resistant, inexpensive, all synthetic monomer. Because of its high abrasion resistance, it is often utilized in tires. For the silicone rubber, we know that it's made up of polymeric chain with a sturdy composition. It is combination of silicon and oxygen atoms in the backbone and range of organic side group connected to them. For the property of XR, stunted glass transition temperature, excellent temperature resistance, good electrical resistance, and low temperature flexibility. For the butyl rubber, IIR, we know that it's an isobutylene copolymer and has modest amount of isoprene added. At low temperature, it is polymerized. So we can see this is the structure of butyl rubber. For the property of IRR, we know that IRR extremely low gas permeability, extremely high damping qualities, excellent edging stability, poor resistance to lubricant and fuels, low adhesion properties, excellent weather resistant. For the thermoplastic elastomer TPE, a copolymer and physical mixture of polymers that contain components with both thermoplastic elastomeric qualities, also known as thermoplastic rubber. This is the structure of TPE. For the properties of TPE, we know that TPE has extremely elastic properties, have weaker dipole or are hydrogen linked, excellent molecular weight, and also high strain. This is my reference, as you guys can see. And that's all from me, Africa Binti Ujang. Thank you. Bye-bye.